All right, this is the second lesson on percentiles and quartiles, and we call it applications. There's not much of an application here, but there is a little one. There's a bit of a new question, but for the most part, we're just practicing percentiles and quartiles. And again, this is, it's kind of some tricky stuff. There's a few very particular steps that you have to do, and you kind of have to just keep in mind. Like you have to sort of actively be thinking about a few important things when you're doing the quartiles or calculating percentiles. So, um, to me, that's what you really want to focus on when you're doing this work, when you're doing this practice. You really want to make sure that you are not forgetting the couple of little important steps, just because they're easy to forget. A lot of people forget them, and so you want to, like I said, be actively thinking about these important steps. Okay. Um, so let's take a look. The following data. So I'm going to write down as we're going. I'm going to make a couple of notes. That's why I have some space up here at the top. Okay. So I'm going to make a couple of notes on just important things that I want you to be aware of and think of. And when you're doing a question on percentiles and quartiles, you think to yourself, oh, these are the things that I have to remember, right? And if you do that, then hopefully everything else will fall into place. So the question we're looking at is the following data are the hourly pay rates in dollars per hour for 17 high school students. Now, this is, I guess, kind of what makes it an application. The last example that we did wasn't about anything. It was just random numbers. Okay. And so in this case, we're actually doing numbers about something. And um, that doesn't change most of what we're going to do. So the fact that it's an application isn't going to matter too much. Like I said, there's one question that we have to answer. That's a common question in these application type questions. That's a bit new, but it's pretty straightforward. Okay, so for the most part, we're really just, it's more practice of the same stuff. Okay, it tells us that there's 17. That's always important, knowing how many data points we have in total, and it's got the data points listed. And the first question is, what are the quartiles? Now, right away, one of the most important one of those important points that we need to be aware of um, is going to happen right now. So again, if we compare this to the last example that we were doing, now this data set had 50 numbers, and they are in order. Okay, so this is the important point. Now, we would never give you 50 data points that you would have to put into order. If there were that many data points, they will already be in order. It's probably always something you should look at. In the real world, whenever you're doing something with large data sets, you're going to be doing it on a computer, probably in a spreadsheet, and spreadsheets are very good at ordering data for you with a couple of little clicks. So it's not something that you're going to have to do manually, generally speaking. That being said, when we look at this data, we see very quickly it is not ordered. And like I said, that's a trick. The data has to be in order to do the median and percentiles and quartiles. Okay. We did averages, so means and modes, and the data doesn't have to be ordered for that. It's helpful for mode, I guess, because you can see the data points in a row. But for mean, it doesn't have to be in order. But for median, it absolutely does. And for percentiles and quartiles, it absolutely has to be in order. So this is a very common mistake. On a quiz or a test or an assignment, we might give you 10 data points. Some of the questions in the assignments that we do in this course might be upwards of 15, 16 data, 17 data points, something like that. So this one has 17. So this is about as long as it gets that we would probably see, at least in this course, where you're given these data points and you have to put them in order. So it's a bit of a pain, but it's not that hard. Okay. And we're going to talk about a little trick to make sure that we do it correctly. And like I said, compared to the last one that we did that had 50 data points, but these were already in order. Okay, so that's always something you want to think about and not take for granted. So the first thing we have to do, like I said, is put them in order. And I'm just going to scan through and find the smallest. So the smallest is 9.5. 0, and I'm going to write that down, and I'm going to cross it off, and I'm going to cross them off as I go, and that will make sure that I keep track of the ones I've used, and hopefully I won't miss any, and I will actually get them in order. Okay. There's no more 9s, so there's a couple of 10s. Looks like that's it for the 10s. There's a 10.25. What other 10s do we have? Oh, that looks like it. So 11. By the way, you can pause the video now and do this yourself, and check your answer and make sure that you've carefully done it correctly. So I see an 1150, an 1175, and 1145. See, again, it's easy to miss one. If you miss one and you go too far, you're going to be mad at yourself because you're going to have to go erase and go all the way back. I don't see any other 11s. Looks like all the 12s. Now, I think I'm done. I can clearly see that I've got all 17. I've crossed them all off, but also I ordered them. I sort of grouped them the way that the original question was grouped. I did that on purpose so that I could make sure that I have them all. Sometimes you're told how many there are. Sometimes you have to count them yourselves. Knowing how many there are is an important part of the process. So I can see that I've got 4 and 4, which is 8. Another 4 and 4. Another 8, that's 16. Plus the final one is 17. And I decided to sort of group mine the same way, just to keep track and make sure that I have 17. Some people might want to try to fit them all on one line. If you only have a few data points, that's usually easiest. It's easier to be counting from both sides when it's all in one line. But, you know, with 17 data points, it might be hard to fit in one line on paper. So I did it this way. So again, I can see that I've got 8, 8, and 1. So 16 plus 1 is 17. So I've got all of the data points. Okay. So when we're doing, okay, so I want to make a note of that, sorry, must be in order. Okay, so I think it's a good idea to write these important points down and keep them in mind when you're doing this, and think about these few important and common mistakes that people make, okay? Now, when I'm finding the quartiles, some of the questions sort of walk you through it. This one just says, what are the quartiles? So something that you want to know is we're always going to find quartile 2 first. We're always going to find the second quartile, which is the median. We are going to find that first, okay? So I'm going to write that down, Q2, which is the median. You don't have to say that it's the median, just because we know how to find the median, it's useful to remember that that's what we're doing, okay? And there's a couple of ways that you can do this. Remember, we can use the number of data points to determine where the middle is. So whether you have an even number of data points or an odd number of data points, it's a little bit different, okay? But for the median, I've got 17 data points. If I divide that by 2, that gives me 8.5. Therefore, our median, or our second quartile, is the 9th value, okay? So that's one way of doing it, and then we just count one. Oh, I know that there's 8 in the top row. So there's our second quartile, 11.45. The other way to do it would be to cross off But like I said, it's a little bit tricky doing this when it's not all in a row. So you kind of have to be careful and focused. Now I'm going to get rid of those because it is going to get too jumbled up. But you could also just cross off or just use your fingers to follow in from the sides to figure out where the middle one is. Okay, if you have a very large data set, that might take a long time. So counting which is the middle data point is probably better, calculating it. And then you can just count, right? So we got 1, 2, 3, 4, 5, 6, 7, 8 in the top line, and Q2 is $11.45. Okay, then the other two, it doesn't matter what order that we do them in, but usually we do Q1 next. Okay. And so I've got 8 below Q2 and 8 above Q2. So when I'm finding the middle of those 8, it's going to be the 4th and the 5th. So it's going to be the middle of those two, right? So just like median, if we have an even number of data points, we take the two middle values and we take their average. And again, when we're doing this on our calculator, we have to be careful about how we type this in. If I do this, I'm going to get the wrong answer. Okay, and I know that's wrong because this is an average, so the average has to be between the two values, and 15 is not between the two values. So again, you can do a mental check to make sure that you're on the right track. But what did I do wrong? I made a bedmass mistake here, the way I typed it into the calculator. So I have to either tell the calculator to do those two first by putting them in brackets and then divide by 2. Okay, and so that's going to give me the right answer, or hit equals to get that value and then divide it by 2. Okay, and so I'm going to round $10.13. And that's per hour. These are all per hour. These are hourly wages. So if we're including units, we want to write that down appropriately. Third quartile. Again, 1, 2, 3, 4. It's going to be these two middle values of the upper half of the data. And again, like this is another thing that you need to think of. Do you have an even number of data points or odd number of data points? Let's write that down. Even or odd, or odd data points. Okay, and that counts for the total data points, but it also counts for when you're doing the first and third quartiles. In the bottom half of the data set, is there an even or odd number? All of that stuff, right? So that's something that you really do need to think of. So for this one, we're doing 12.75 plus 13.25. And that works out to $13 exactly. Again, so $13 per hour. Again, being careful of brackets, right? Just make sure you punch that into your calculator properly. So there's your 3 quartiles. So you always start with the second quartile, and then you can do the first and the third. That's something that you need to know. You need to have them in order, and you need to be aware of whether you have even or odd number of data points. Okay, next question. Nicole's pay is in the 85th percentile. What does this mean? So notice that this is the new question that we have. The other ones, sure, they're about a real life problem, so it's an application, but again, it doesn't really make the work different. But this is a new question that we often see when we're doing these quote unquote application kind of questions. And this just comes down to the definition of what a percentile is. It means approximately 85% of students earn, and this is the important part, less than Nicole. Right? So 85th percentile means she's above 85%. She isn't at 85%. She's above 85% of people. It's a bit of a strange thing. It's a little bit unintuitive, but that's what that means. Okay. So you just always want to use the words less than, or you could say Nicole makes more than 85% of other students, right? Of all the students. She's more than 85%, or 85% are less than her or below her, right? So there's two different ways that you can say it, but you do have to be a little bit careful about how you word that, okay? But that's that question. What is Nicole's hourly rate of pay? So we know she's the 85th percentile. So first of all, we have to find out what 85% of 17 is. And again, that's why we need to know the total number of data points. And to find that, we do 85 divided by 100. And of in math means times 17. So again, I'm just going to do this on the calculator. $14.45. And here's the final thing that we want to talk about. And this is going to come up a couple of times, okay? But it's the same idea. We always round up, because Nicole has to be above, this is what we just said, above 85%. When we find 85%, even though 14.45 would technically round down to 14, we always round up, okay? So that's our last point here. Always round up. Okay, now be careful not to take that too crazy. That doesn't mean in the entire unit we're always rounding up. It means for percentiles specifically. Just percentiles, we're always going to round up. Okay, so we have to round up to the nearest data point out of 17 points. She can't be halfway between them. She's either the 14th or the 15th. So she has to be the 15th, so that 85% is below her hourly rate. Now, I think one of the main reasons, at least for me, why this is kind of weird and kind of tricky is because we have so few data points. Often in percentiles, the first place you might encounter this is if you take any kind of proficiency test. So like they used to do IQ tests, they don't really do those anymore, but they still do things that are similar to them. So if you're getting any kind of psychological testing or academic testing, even the SATs, something like that, you might see percentiles. Or if you become a parent, or if you have siblings or friends who are parents, they talk about percentiles with children. So they talk about a child's height being a certain percent, being at a certain percentile, or their weight being at a certain percentile. And that's a place that you commonly see this, okay? And that's compared to thousands and thousands and thousands of other people. So it makes sense to say you're the 85th percentile. In this case, because there's only 17 data points, it's tricky, and don't get too hung up on this, but like you're the 85th percentile, but you're also kind of the 86th or 87th or 88th. Like there's so few data points that there's kind of a range of percentiles that could make sense for this. And I think that makes it tricky. But again, if we had too many data points, then it would be too hard to do this math. We wouldn't be able to do it by hand. We would have to use a computer to do it, and we probably wouldn't understand it quite as well. So, bear in mind that we're in the real world. these percentiles have a bit of a more definitive meaning, and they make a little bit more sense because you usually are talking about them in reference to very large data sets, thousands, tens of thousands, hundreds of thousands of data points of people or whatever it is. Okay, so keep that in mind. But our rule, we'll just stick to the rule. That's the easiest way for us to do it, is remember, always round up. So she's the 15th. So now I count to find the 15th. So I've got 8. 16 takes me to the end of this row. So the 15th, that's Nicole, 1350. So we were asked to actually find her rate of pay, not just find what her percentile was or what we were given her percentile or what her position was. So we have to actually state the final answer. That's another common mistake, that people forget what the answer is actually supposed to be, similar to the example that we did in the lesson before this. Okay, and finally, this is our last question. What percentile is 1220? So I have to find 1220. And here it is. And I have to figure out what number that is. So again, I can't use the unordered data. It has to be in order. That was our first point that we made. We have to always be using the ordered data. So let's see, 1, 2, 3, 4, 5, 6, 7, 8 to the end of the row, 9, 10, 11, 12th. So 1220 is the 12th. Therefore, we are going to figure out what percent is the 11th, because percentile is always about how much is below. Okay, so this isn't rounding down, because I said always round up, and some people might say, well, now you're rounding down. Well, we're not rounding down, but we're if 1220 is the 12th, we have to figure out what percentage is below that. So we always go down to the 11th. And again, this is sort of part of what makes this so tricky, is remembering all these little steps, particular steps. If you don't do that, then everything you're doing is wrong, right? So do this on our calculator. 11 divided by 17 times 100. 64.7. And again, always round up. We're going to round up to the nearest percentage point above the 64.7. So therefore, 1220, I can even put it here, therefore 65, $1220 per hour is the 65th percentile. They're called percentiles. Again, we talked about this. They're called percentiles because they have to do with comparing them out of 100, but they're not percentages. It's not a percent. It's a percentile. It's a different thing, and it's really important to make that distinction. And look at both of these cases where we round up no matter what, right? In the case of part D, 64.7 would naturally round up to 65, but we would round up no matter what, because if we round down, then we're actually not necessarily getting the amount that is below in this case 1220, right? Whatever the question is. So we're always going to round up, and that's going to keep us safe. And you can have decimals in percentiles. You could be the 64.7th percentile, like that would be fine. You could round it to one decimal place, but we're going to round to the nearest whole number every time. And that's going to make it easy. And if we always round up, then we always know that in this case, the 11 out of 17 is definitely below, 1220 is definitely above 65% of the data, because it's above 64.7%, right? So it's definitely going to be above that. And again, this is a little bit tricky. We're not going to be too worried about the specifics because we're dealing with such small data sets. It makes it a little bit less meaningful, almost a little bit, the whole rounding part becomes a little bit tricky with small data sets, but the math is the same, and with a large data set, it would make more sense. Okay, I hope that's clear. Again, that's applications. The only difference is we've got units because the numbers are about something. We often have a question like B here where it says, what does this mean? And we have to answer that a specific way. And again, these important points that we made, don't forget the data must be in order. Large data sets will be given to you in order. Smaller data sets might not be in order. So that's the first thing that you have to think about when you come across any of these questions. You want to think about whether you have an even or odd number of data points, and you want to make sure when you're dealing with percentiles that you are always rounding up. Okay, and that is applications of percentiles and quartiles.